Hello, welcome to Kofi J's class. Please, if you are new to this channel, please subscribe and be part of this class. And for my subscribers and those who have been watching my videos, thank you very much for always coming along. I'm on holiday in Ghana, and today I am in Methodist Technical Institute. I have some of the students here as my subscribers, and today I'm here to visit them and also give a lesson and take you around the school as well. Come with me. Hello, welcome to Kofi J's class. As I told you, today I'm in Methodist Technical School or Methodist Technical Institute in Sunyani. I have some students here who are my subscribers, and I'm here on holiday and I'm in Sunyani. So I tried to come to this school and meet some of my students. So today I'm going to give a free lesson to these students. And after the lesson, I will take you around. So take your drawing boards, your drawing instruments, and let's get started. So guys, today we are going to draw an orthographic projection. We have a figure, and the figure is in isometric projection, and we are going to draw the figure from isometric projection to orthographic projection. And in the orthographic projection, today we are going to use a first angle projection. First angle projection. Are you okay? Yes, sir. I have this figure here, and we are going to draw this figure in first angle projection. So the first angle projection, we are going to draw the plan of this figure, the front view or the front elevation, then we have the end view or the end elevation. But first, we are going to use a scale of 1:10. Our scale is 1:10. So the distance from here to this side, we consider this to be 600 millimeters. And 600 millimeters, the scale 1:10 will be 60 millimeters. Or 6 centimeters. The distance from here to this side is 600 millimeters of scale 1:10. So it's 60 millimeters. You divide it by 10. So it's 6 centimeters. Then we have from here, this side is also, it's 400. So 400, you divide 400 by 10, 40 or 4 centimeters. Then we have from here 600. So here is also 60. Here is also 200. So here is also, the distance from here to this side is also 200. So it goes from here to this side is 600. 200, 200. The distance from here to here is 200. From here to here 200, 200. It's 600 millimeters. As I told you, this figure is in isometric projection. And we are going to draw this figure in orthographic. We are changing from isometric to orthographic. Isometric to orthographic. So this figure is in isometric, and we are going to draw this in orthographic projection. And as I told you, we are going to draw the plan of this figure, the front view or the front elevation, then the end view or the end elevation. And we are taking our front elevation or the front view from this direction. So in my class, I always use my T-square to divide my drawing sheets. It sometimes makes it very easier for the students. You draw a straight line, you draw another line like this, then you measure 10 millimeters, then you draw another line, another 10 millimeters, then you draw another line. Then here as well, you measure 10 millimeters, then you draw another line, 10 millimeters, you draw another line. So it helps you to draw your orthographic projection. So now we are going to start with our plan. And the plan is looking from the top of the, so it's like looking from this direction, so that we are going to get the plan of this figure. So before you can get the shape of or to get the plan, it's always very important to consider the base, the shape or the size of the base of your figure. So when we consider this, we know here distance from here to this side is 60 millimeters or 600 millimeters with a scale of 1:10. So we have 600 millimeters here, and we are taking our front view from here, and the distance from here to this side is also 400 millimeters. So from here, after drawing this line is it's a faint line, it's a constructional line. So you just measure 600 millimeters from this distance from here to this side. So if the distance from here to this side is 600 millimeters, you mark your 600 millimeters here. Then with your t-square and your set square, then you draw a line, a faint line like this. Then the distance from here to this side is 400 millimeters. 400 millimeters. So from on this line, you measure your 400 millimeters. Let's take our 400 millimeters to be at this point. Then you draw another line like this. So as I told you, you consider the base. So we have the 600 millimeters and the 400 millimeters. So now we have this. We are drawing the plan of this figure. Then after drawing, as I told you, you consider the base. We have this by this. After getting this, then you look from the top. So from the top, this is what we are going to see. We are going to see these areas. Here, here. This from the top, this is what we are going to see. All this area. So we are going to see here, this and this. So we have this line to be this line. Because this line is parallel to this. So it's the same. So we have this line, we have this line here. So from here, the distance from here to this side is 200 millimeters. This is 20 millimeters or 2 centimeters. Then you mark with your compass or your divider, you measure 20 millimeters or 2 centimeters. Then you mark your 2 centimeters somewhere here. Then the distance from here to this side is also 20 millimeters, because it says from here to here is 200, and then from here to this side is 600. So if here is 200 means the distance from here to here is also 200. Then from here, from this, and this line is this line, because it's parallel to the line here. So you measure 20 millimeters, then you mark your 20 millimeters somewhere here. Then you, with your t-square and your set square, then you draw a line, straight line to this side. This is freehand. That's why you see the lines moving. Yeah. So we have this. So when you consider the top of the view, looking from the top, this is what you are going to see. We have these lines and this line. And we have a hole here. We have to indicate on the plan that there is a hole. But when you look at the top of this figure, we have these lines here. And from the top, we need to show this. So you can leave, because you can get you can still indicate the hole through the end view. So when you make a hidden line or broken line here, it means there is nothing here, but we have something projecting here. So we have to leave this, and later we can indicate on our drawing that there is a hole through our end view or end elevation. Any questions so far? I will stop now, and if you have a problem or question, you can just ask and we'll continue.
We started from the plan.
Okay, from the plan, okay. Yeah, you can sit down, thank you. Yeah, he's asking why I started with the plan instead of the front view or the front elevation. But now with the technical drawing is now, even when you go to some schools now, they use computer to So when you look, even when you look on the internet, you see some of the teachers, they don't even use the drawing instruments. With the computer, it's very easy. So you see everything is 100%, but drawing you cannot get exactly 100. So this is the very technical drawing. You need to use your drawing instruments. But you can choose. Now you can choose to draw the front view. If the front view, drawing the front view first is easier for you, you can still draw the front view. Because when you draw the front view, it's like you draw the front view of the figure. You would still need to transfer all the lines down here to get the plan. In this way, after drawing the plan, you will still extend all these lines up. So when you extend these lines up, it's also help you to get the front view or the front elevation. So you can choose to draw the plan first or the front elevation first. Yeah. Okay. She's asking if the plan is going to be a faint line. Is this what you ask? No. After drawing this, then with your pencil, it's not a faint line. Then you show the lines. It's not faint lines. It's not faint. So we have this. Then now you can see the plan. So this is the plan. It's not faint lines. After this, after drawing the plan, is that clear? After drawing the plan like this, then you use your T-square and your Z-square to extend all these lines up. And these lines are going to be faint lines because you are going to use that lines to get your front view or the front elevation. So with your T-square and your Z-square, you just draw faint lines like this. It goes like this. So now we are going to draw our front view or the front elevation. Do you still have some questions to ask? All right. If there is no question, then we continue from here. Yeah.
I want to ask, can we also start from the end elevation?
No. Before you can get the end elevation in orthographic projection, you need to get the front in first angle projection. You need to get the front view or the front elevation, the plan before the end elevation. The end elevation or the end view is the last part of it. You need to draw the front elevation, the plan before the end elevation. So we are going to draw the front view before the end elevation. Is that clear? Good. So now we have this. Now let's look at the figure here. Now with the plan, we now have this line, the distance from here to here, which is this one. It's here already. Now we consider this. The distance from here to here is 600 millimeters. So you measure 600 millimeters. Let's take the 600 to be here. So we have this. So we have this to be 600 millimeters. We have this. Then the distance from here or from this side to here is also 200. So here, you know, this portion or this area is this. Right? The part which is projecting here. So it goes like this. So here you measure your 200 millimeters here. So this line is just a faint line. You can just that is the distance from here to here is 600. So you measure from here to here your 600. From here to here your 600. Then we have from here to this side, which is 200. then you can get it from here, because this area is this. That is the part which is projecting. So it goes like this. So from here you measure your 200 millimeters or 20 with a scale of 1 to 10, that's 20 centimeters or 20 millimeters or 2 centimeters. Then you measure 2 centimeters. Then you with your T square and your set square. Then you draw these lines. So after this, then you just join these with your T square and your set square. All these are faint lines. So we have this. Then we have the hole here. And the distance from here to here is 200, 200, 200. So it's the same as the distance from here. So from here, and the distance from here to this side, 200. So from here, and this portion is the hole. Look at this side. The hole is the center, because it's 200, 200, 200. And from here to this side is also 200. So you just measure 200 here. It goes like this. And from here to here is also 200. So you get your 200. So with your T square, you just draw a line like this. So this is the front view or the front elevation of this figure. So when you look at the figure, the front view, this direction is going to be this area. And the hole. So this is the front view or the front elevation of this figure. Any question? So now we are going to draw the end view or the end elevation. But so far, do you have a question? Do you have questions to ask? Do you have questions? All right. Then let's draw the end view or the end elevation. And after drawing this, then with your T square and your 45 degree set square, you draw with your T square and your set square, you draw your 45 degrees angle to this side. Then you extend this line, and this one is already there. Then with your T square and your set square, you just draw this end. Then extend all these lines to this end. So from here, you just the faint line, it goes like this. This one goes here, this one goes here, and this one goes like this. So we have this. So with the help of these lines from here and this, we just get our end elevation. It's very simple. After getting if you are able to draw your front view or your plan, after extending all these things, if you know how to draw, then the end elevation or the end view will be very simple for you to draw. So now we have these lines. So we are going to this area is the end view we are going to get. We are going to see this side, this area here, and this area and this area as the end view. So now from here we just draw our straight line. We are going to get our straight. We have this line. This line is the same as this line. It goes like this. Here is the same. because the distance from here to here is 600 millimeters, and here is 200 millimeters. So first, you just draw your with your t square and your z square. You just draw this. Then we have this line. We are going to see this line, the first one here, which is here, the base. We have this. Then we see this line is parallel to this line, so it's the same. So we have this line. But before that, let's consider the whole. I told you the distance from here to this side is 20, and here 20. So this, and you can, from the front view or the front elevation, you can see that this is the whole. So this area or these two lines are going to help us to indicate the hole in the figure. So we are going to draw our hidden line or our broken line. Here it's like this. This indicates that there is a hole in the figure. This hole. Because from here, you are not going to see the hole, but you have to indicate that there is a hole in this block. So we have this hidden line indicating that there is a hole in this figure. Then we have, as I told you, have this, that is the base, which is here. Then we have this line. We can, from this, it helps you look at this side, which is here. So we have this line here. So this is also, you join this line. Then the last, which is this one, you join this. So we have this to be the end view or the end elevation. So from here, you see this area and this area, which is here and here. But we have a hole here. So we have these two lines indicating the hole in the figure. Okay. Now he's asking why is it important to outline our work? Because now in orthography we have all these lines. All these lines are constructional lines. They are all constructional lines to show the work you are doing. So this is what we are doing. All these lines, it helps us. These lines help us to draw this, to draw this figure into orthographic projection. So we need to show our work. All these lines are construction lines, so the lines are not the same.
How is it important to show the hidden?
She's asking why is it important to show the hidden details of the figure. Now, in orthographic projection, it helps the engineers or the technicians to work on the field. If you want to build a house, I don't think you can get a plane or a drawing sheet which is bigger like Cuckoo House to build that, to draw that building on a paper. So we use a scale. That's why we have a scale. Then with this, when you get this, then the engineer or the technician will know that when the technician sees this slide, you know that there is a hole or a space or a gap in the block or the figure. So without the hidden line, when you make it a straight line, it means there is a joint or something like this here. Meanwhile, here is just a straight, and there is nothing here. So the hidden line helps us to understand or know that there is a gap or a space in the block. Any other question? Yeah.
Sir, please, what is the application of orthographic projection?
The application of orthographic projection. The application of orthographic projection, as I told you, after getting, when you have orthographic, if you have this sheet, a technician, when you are given this sheet, a good technician will know that this will be that is the assembly. When you assemble this, when you assemble this drawing, you will get this. So if you are on site and this you get this sheet, that you have to whether it's a C&J department or building department, and you get this, then you know they are asking you to mold this or form or build this figure. So when you look at this, you look at the plan, the front view and the end elevation, then you know, this block, the base is 400 by 400, and the distance. Then with this, you can draw this. That is assembly drawing. So when you assemble this, you get this figure here. Oh, good. Yeah, you have done well. But you know, you have to show this line. You have to show this still construction line. Yeah. Are you done?
Yes, sir.
Okay. Oh, good. Good. You have done well. So guys, thank you very much for coming with me to Methodist Technical Institute in Sunyani. But if you're new to this channel, please subscribe and be part of this class. And for my subscribers and those who have been watching my videos, thank you very much for always coming along. I will see you in my next class. Students, say bye-bye to my subscribers and my viewers. Bye. Okay. See you in my next class. Bye.
Ordering of application.
Guys, I have the vice principal here, Mr. Katechi Abraham. Yeah, Mr. Katechi Abraham, please can you tell us the type of courses your school offer?
Oh, okay. Thank you very much for the opportunity. Yeah, this is Sunyani Methodist Technical Institute. We offer programs or courses like building and construction technology. We also offer electricals and electronics engineering technology. We also do electronic engineering technology. We do welding and fabrication engineering. We also do auto mechanics, which we normally refer to as motor vehicle engineering.
Yeah.
And then we also do wood construction technology. Then we do building construction technology. We offer fashion and designing here, as well as catering and hospitality management.
Oh.
Yeah, so these are the courses that we offer in this.
I think you have all the
Oh, yeah.
Almost all the technical
Yes,
courses
almost
here.
all the technical
Oh,
courses
good,
are being
good.
run here.
So,
Technical drawing,
so
all of them.
Oh, good, good, good. Please, can you tell my viewers the location of your school if someone want to come here? The location.
Thank you very much. Sunyani Methodist Technical Institute is located in Ghana, West Africa.
Yeah.
Specifically Ghana. Yeah. And when we come to Ghana, we have our regions. Yeah. And here is Bono region. And the capital is Sunyani. So the school is located or situated in Sunyani. If you want to come to our school, on the Sunyani Bakuniaba Road, that is where you can locate the school. Oh. Those of you who are using the digital address, if you have the digital address, you can also trace it through the digital address. Oh. And it is BS-0038-6886.
Oh, good.
That is our.
But I think I also saw the school. The school have a Facebook group, so through Facebook you can also check their Facebook page. That is Methodist Technical Institute.
Sunyani Methodist Technical Institute.
And do you have telephone numbers if someone want to call?
We have telephone numbers or our contact numbers. We have 0, that is 233.
Yeah, that's the Ghana code.
Yeah, 233. We have 0244 114921. Then again, you can also use another line, which is 054 086 5392. Any of these numbers, when you call, we are ready to answer any question that you have for us.
Thank you very much, Mr. Katechi.
You are welcome,
Abraham.
Sir. Thank you.
Yeah, so guys, you can check the school on Facebook. You can follow the school.
Yeah, those of you who also want to also get us through the email, we have the email address. That is Sunyani Methodist Technical Institute.
I'm going to leave the telephone numbers and the direction and their Facebook contact address, everything on the description box, so you can check. You can get all the information on the description box. Thank you very much, Mr. Katechi.
Thank you, sir.